All right, so let's talk about a couple protocols beyond HTTP. For example, DNS. DNS is, of course, good, clean fun. If I open this one, this page, this page loads content from multiple servers. It loads every few seconds, it connects again to a different server number. So it just keeps doing DNS requests for all these different server numbers. And I'm not having luck with my Wireshark on this machine. But if I could, you could load Wireshark and you'd see it making all these DNS queries that you see here, calling this one and that one and that one. So that's all it does. All right, so we're going to make, now monitoring DNS is really valuable in security. If you monitor your DNS traffic on your network, you can tell what people are doing. And if people are doing something you don't want them doing, like going to games or social networks or porn sites, you can see exactly who did it, when they did it, and where they went by just recording DNS lookups. And this is why a lot of people got real upset when DNS over HTTPS started becoming popular. So DNS lookups are encrypted because that robs the security team of this very handy monitoring technique. But if you don't have the encryption turned on, you can do this. And so we're going to use Scapy. Now, I don't know if I'm going to have Scapy work on my Mac. Let me try it and see. I might. Well, okay, it's downloading Scapy. That's good. Sometimes I've had trouble running Scapy on the Mac, but we're going to see. So let's run, see if this DNS works on my Mac natively. And if not, I'll have to make it on my Linux machine. So nano DNS1.py. This will import the functions from Scapy. This will start sniffing. This is a Scapy function. Scapy is a Python network capture library. And when it finds something, it will call the find DNS function. And that will look to see if it's a DNS packet. And if it is, it will print information about it. That's all this does, is that. So let's see if this works. Python 3 DNS. Okay, permission denied. Okay, I thought that might happen. Let's see if I can run it with sudo. This is what happened to my Wireshark too. It needs administrator permissions to snip on the network card. And okay, okay, it might be working. Let me open that page again so it does a bunch of DNS lookups. Oh, looks like it's working. There they are. DNS lookups are happening. Okay, good. So it's telling me all kinds of information about DNS lookups like this one. In fact, it's telling me far too much information. So it's sort of flooding the screen with junk. I would like it to be a compact display like this, but we're on the right track here. So here's a cleaner DNS monitor. DNS2.py. Okay, all this is going to do is print just the summary, not the complete information about every packet. So let's see how well this one works. Again with sudo on my M1. You probably need that on all your machines too. There we are. And there it is. Now it's showing just the query, and then there's an answer. But this is friendlier. I now know this IP address went to that server, this IP address went to that server. This is better. And so now you've got some challenges. Here's one where you'll find a lot of nonsense, but eventually the flag is just going to be right there. Now, another thing is to know about is that bots, when you get infected by remote control bots, the bots often communicate over DNS. They will send DNS messages out that contain encoded data, encrypted data in random letters like this. So you'll have what looks like a DNS request, but it is in fact exfiltrating data from your system that's encrypted. And that's what we're simulating here. So here's one, and they're getting more and more difficult. And you'll find that some of these are imitating what real bots do. They're hiding the information. And this one here, you have to find a request different from others. They're each hidden in more and more nasty ways. So some of them have actually got the DNS, the data you need encoded as hex values, encoded in binary, and encoded in base 32, which is, by the way, the preferred way to encode DNS requests, because in DNS requests, uppercase letters are treated equal to lowercase letters. So you can't use base 64, you use base 32 that just uses the numbers and the letters. Anyway, these are just some challenges where you get to extract data from more and more obscure DNS requests of the type you'd see in bots. And I think the next one is more of the same. You can also do the same thing with HTTP. So here is an HTTP sniffer that does the same thing. Let's do that. This is going to be HTTP1. This does exactly the same thing. It imports SCAPI, then it sniffs, and when it finds a packet, it calls this function, which looks to see if there's TCP on port 80, and then it prints the information about it. And again, I've got a page that simulates that you've been infected by a bot that keeps making HTTP requests, exfiltrating data. And it is, I think, doing it, although you can't see it. Let's see if I run that script with Python 3 and sudo. Yep, there goes some HTTP requests with, again, far too much information. Notice this long random series of letters in the file name. So it attempts to load a folder, but that long name, that's just another place where bots will hide information in any field that can carry a lot of random letters. So that's this one. Again, you can make a cleaner one that doesn't print out so much excess information. That's going to be HTTP2. This is going to look, and if it has a raw later, it's only going to print the load. So it's not going to print all the port numbers and protocols and addresses. It's just going to print the data that was sent, which should clean it up. So that's HTTP2. Okay, and there's the data, which is still pretty messy. That's a GET request. And there's another GET request. Let's stop this and see if we can isolate the active ingredient. All right, so what you got to do is find the folder names, which are in that mess somewhere. Get VP. There, here's one. Here's an example of a good one, an interesting one. It has get and then this long chunk. So you'd have to make a cleaner version of it that shows just this information and not all that other junk like this. And then you can start finding things. One of them will have a flag in it, and one of them will have a hex encoded flag and encoded in various ways. And for some ungodly reason, I went so far as to use base 58 here. Folder names do let you have uppercase and lowercase. Base 64 can be used. Base 58 is a bit of madness from Bitcoin, but I added it in here. You can do that too. Anyway, those are a few challenges to detect obfuscated traffic on your network with Python. I see a chat message. Python not working for me, and also the same with Wireshark. Yeah, okay. Let me see if I can handle that. Let me stop this recording and let's see if I can debug that.